Hello there and welcome to a brand new lesson. This is Have Your Numbers, where we learn maths the easy way. In this lesson, we are looking at factorization of polynomials. By the end of this lesson, you should be able to use the factor theorem to find the first factor of a cubic polynomial. You should be able to perform polynomial long division to find the quadratic quotient. You should be able to factorize the quadratic quotients completely. You should be able to write cubic polynomials in fully factorized form, and finally be able to solve cubic equations by factorization. As this lesson proceeds, you realize that I'll be using these vocabularies. The first is the cubic polynomial. When we talk of a cubic polynomial, it's simply a polynomial with a degree of 3. The rational root test, we'll be talking about it in the lesson. Then after dividing your polynomial, what do you have as the quotient? We call it the depressed polynomial. And writing a polynomial in its fully factorized form simply means you are writing it as a product of all of its linear factors. Without much ado, let's quickly look into it. So let's start by first of all looking at what it means to factorize a polynomial. When we talk of factorizing a polynomial, then we simply mean that you are rewriting the polynomial as a product of lower degree polynomials. You see, you are rewriting it. For instance, if we have this polynomial here, this polynomial is of the degree 3. You see, so if you want to factorize this, then we are rewriting it as a product. You know, this bracket here is multiplying this one, and then it's also multiplying this one. Only this polynomial has been rewritten as the product of these 3 polynomials. You see, that is what we mean by factorizing. But why do we even need to factorize? If you're able to factorize, you're able to find the zeros of a function. So we factorize in order to solve equations. We factorize in order to find the roots of the equation. When we talk of the roots, then you're actually finding where the graph touches the x-axis. You see, that is the x-intercept. We factorize in order to be able to simplify algebraic expressions or functions or fractions. And we also factorize to understand the behavior of polynomials. So in a nutshell, the key idea is if a polynomial is written as a product of factors, we quickly solve for its zeros. You see, it helps us to solve for its zeros. With that said, we want to master how to factorize the cubic functions. Now, a prerequisite for this is that you know how to factorize quadratic functions. So let's look at the step-by-step process. First of all, to factorize a cubic function, you need to find one of the roots. You see, in finding one of the roots, we use the rational root test. By the rational root test, what we mean is if you are given a polynomial, so let's say for this polynomial we have here, which was an x cubed, then minus 2x squared, minus 5x, and then plus 6. So what you do is you take this 6, that is especially if the coefficient of x cubed is 1. So we take the 6 and we find all the factors of 6, both the positive and negative factors of 6. So for the positive and negative factors of 6, we can start with the plus or minus 1. We can start with the plus or minus 2. We can start with the plus or minus 3, and then finally the plus or minus 6. You see, then what you do is you substitute each for the x. So you can start with if x equals 1. You see, then you'd evaluate the function at 1. You can also evaluate the function as negative 1. The main thing we want to achieve here is to get the value that gives the function a result of 0. And with the result of 0, then our mind should then be going on the factor theorem. Because the factor theorem says anytime you evaluate a function at a particular value of x, and then you get an answer which is 0, then it simply means that value is the root, and hence it becomes a factor of the polynomial. You see, so if you're able to get that as the factor of the polynomial, all we do is we then divide. You see, we go on with our division and we get our depressed polynomial. So the depressed polynomial would simply be the quotient that you get. You see, so the quotient you get. Now, since it is a cubic function, the depressed polynomial is usually a quadratic. So you then factorize the quadratic as well by either inspection, method of factorization, or the quadratic formula. And then you rewrite your cubic as a product of the linear factors you have obtained. This will be best understood if we solve some examples. So to have a feel of what these processes are, let's look at this first example. This is a basic cubic factorization, very, very simple one. So we have p of x. So the polynomial in terms of x is given as x cubed, then plus a 5x squared, plus an 8x, and then plus a 4. So the step 1 says we should first of all find a root. You see, we should find one of the roots. And how do we do that? We pick this 4 over here. So for the 4, you just look at its factors, some of its factors, but most importantly, it is very, very simple. You know, positive and negative 1 are all factors of every number. So sometimes you don't necessarily even have to look for the factors, just go with positive 1 and then negative 1. You see, then you try with that. If they don't work, then you proceed with the rest. But for now, our factors of 4 are positive and negative 1, positive and negative 2, positive and negative 4 as well. You see, so let's try with the smallest one. So you start by saying at x, or let's say testing for. So we'll say testing for, let's say x equals, we are taking one of the factors. You see, we have plus or minus. So let's test for x equals, I'll go with negative 1 first to see if I'll get 0. So that is to say, our polynomial at x equals negative 1 is then equal to, we have negative 1 cube, then plus 5 into brackets negative 1 squared, then plus 8 into brackets negative 1, and then plus 4. Negative 1 cube gives us a negative 1. Then we have 5 times negative 1 squared gives us a 1. So we have 5 times 1. So plus 5. Then 8 times negative 1 gives us a negative 8. And then we have our plus 4. Negative 1 plus 5 gives us a 4. Then the 4 minus 8 gives us a negative 4. The negative 4 plus 4 gives us a 0. So it means all this gives us a 0. That is p at negative 1 is what? 0. With the factor theorem, then it implies that if x is equal to negative 1, gives us p of negative 1 equals 0, then x plus 1 is a factor. How do you get to the x plus 1? You know, your factor here was actually x equals negative 1. So in other words, what you want to do is you want to rewrite it so that it becomes x plus 1 is equal to 0. So we are taking this component of it, that is x plus 1. You see, it simply implies x plus 1 is a factor. So if x plus 1 is a factor, as we claim, then we now go through our long division. Step 3 says we should divide by using the polynomial long division. So with that, let's come here, and then our p of x, which is x cubed plus the 5x squared plus 8x plus 4. And that is dividing what? That is being divided by x plus 1. So the polynomial long division we did in our previous lessons, x divides x squared to give us, x divides x cubed to give us an x squared. X times x squared gives us an x to the power 3. Then 1 times x squared gives us an x squared. If we subtract, we have our 5x squared minus x squared, which gives us a 4x squared. So we have 4x squared plus 8x plus 4. We start the whole division process again. So we have x into 4x squared, a positive 4x. So x times positive 4x gives us a 4x squared. Then 1 times 4x gives us a 4x. Then we do our subtraction again. So it's the same process. Divide, multiply, subtract in that order. So 8x minus 4x gives us a 4x. Then we have 4x squared minus 4x squared, that goes off. Then we have our 4 coming down, that is this over here. So with that, we do our division again. 4x divided by x, that gives us a 4. So we multiply. X times 4 gives us a 4x. Then our 1 times 4 gives us a positive 4. And then we do our subtraction. So that gives us nothing. Now this simply means, using our division algorithm, we have x cubed plus 5x squared plus 8x plus 4 rewritten as this we have here, which is x plus 1 times this we have over here, which is an x squared plus 4x plus 4. You see, you realize that this we have here is a quadratic function, hence we need to factorize it as well, so that we have x squared plus 4x and then plus 4. For quadratic, we know our a is 1, so the factor pairs of 4, that when we add, we'll get a 4 is what? 2 and 2. Hence we have our x squared plus 2x plus 2x plus 4, giving us an x into bracket x plus 2. And then we have 2 also over here, specifically a positive 2. I'm not strictly explaining these because we have done it in our previous lessons, and I do hope you were able to go through. If not, this video will be very, very long. So some of the things, I'll just quickly round it all up so that we can proceed with the subject matter of this lesson. Hence, we have our x plus 2 and then x plus 2. So all we have done here is this factorization we have over here. This one. We have just rewritten this one over here as what we have over here. They are the same thing, you see. So with that, if we want to rewrite what we have here, it's simply x plus 1 and then this, which is rewritten as what? X plus 2, x plus 2. We can simplify it further to give us an x plus 1 and then x plus 2 all squared. As simple as that. So this becomes the factorized form of p of x, which was x cubed plus 5x squared plus 8x and then plus 4. And how were we able to come up with this? First of all, we are given a function. Our function in this case is what? X squared plus 5x squared, x cubed plus 5x squared plus 8x plus 4. So you want to look for at least one root that will make it what? one root. Simply say we want to look for one root. And looking for one root, all we need to do at this point is to do what? Is to look for the factors of this number we have over here. This case it is 4. So the factors of 4, you don't take only the pluses, but then both plus and minus. So you have a plus and minus 1, plus or minus 2, and then plus or minus 4. Then we test. It was by chance I just took this one, hoping it will work. Assuming x equals -1 did not work, then we'll have to go with the next number and try again. So this time around, x equals -1 worked. It worked because it gave us a remainder of 0. Remember the remainder theorem. It says when you have the p of the number, whatever the function evaluates is actually the remainder. And over there, the factor theorem takes it from there and says if the remainder is actually 0, then whatever you have as an x can be rewritten as a factor. So our x is equal to -1 in this step was rewritten as what? X plus 1. You see, then from there, since we have one factor, let's use that to divide the polynomial we have been given. So that is what we did over here. And truly, it confirmed that what there was no remainder. Now, this quotient we have here, which is also called the dispersed word polynomial, is then written as what we have here. So that is our polynomial is equal to the product of the two factors. These two factors here are our factor we found right here, and then the depressed polynomial. Now, the depressed polynomial here is actually a quadratic function. So we use the method of factorization or any of the ones you are conversant with to factorize it, and we then have it in this way, which then can be simplified as what we have over here. Hence, this is the factorization of our function we have over here. Let's pick a few more examples to enhance our understanding. So our next question here, that is example 2. We have x cubed minus 7x plus 6, and we have to fully factorize it. Now, if you pay close attention to what we have here, we have x cubed. There is no term in what? In x squared. We just move straight to x. Hence, let's take our function p of x is equal to what? X cubed minus 7x and then plus 2. We would want to rewrite this so that it looks a standard polynomial. So we have x cubed, then plus a 0x squared minus a 7x and then plus the 6. If we want to factorize, the first step says we should look at the 6 and then we look for 8 factors. But as I've told you, you can always start from 1. You know, 1 is a factor of any number at all, you see. So we can always start from the plus or minus 1, you see. So we'll start by saying we want to test. So testing for what? X equals 1. So for x equals 1, using what theorem are we using? We are using the remainder theorem or the factor theorem, you see. So using the factor theorem. And the factor theorem says if p of x is equal to what? 0, then it simply implies that our x we have here is a factor, you see. So in that case, we say if p of 1 is equal to 0, then it simply implies that x minus 1 is then a factor. So for p of 1, we are going to say we have a 1 cube minus, so with this we can just go with a straight one so that it will be simple. So minus 7 into bracket 1 plus 6. That gives us a 1 minus 7 plus 6. and 1 minus 7 plus 6 gives us a 0. So this confirms that our x minus 1 is a factor. Take note, it is x equals 1 we used to test. But after the testing, instead of x equals 1, we equate it to 0, so that it becomes x minus 1 is equal to 0. So x minus 1 is what we are calling the factor. So since we now have one factor, all we need to do is to do what? Use our long division to determine the remaining factor. First of all, to determine the depressed polynomial. Hence, we are going to divide x cubed minus or plus x squared divided by 7x plus 6. We are going to divide it by x minus 1, just as we did for the previous one. So with that, let me just clean this and then bring the division sign in front of what we have here. So we are dividing this by what? The x minus 1. Let's start with our division. X divides x cubed and x squared. So x times x squared then gives us an x cubed. And then negative 1 times x squared gives us a negative x squared. We then do our subtraction. 0x squared minus x squared, that gives us an x squared. Then we have a minus 7x plus 6. Then we start our division all again. So x squared divided by x, that gives us a positive x. So this x times this x gives us the x squared. The negative 1 times x gives us a negative x. Then we do our subtraction again. So negative 7x minus x, that gives us a negative 7 plus 1, which is a negative 6. So we have a negative 6x plus x, and as we know, these ones are cancelled. We start again. So we have x into negative 6x, that gives us a negative 6. So with a negative 6, we multiply by x to give us a negative 6x, then times the negative 1 to give us a positive 6. When we subtract, we are going to get nothing. That confirms the more that this we have here is really a factor. Hence, our function p of x can then be rewritten as the product of these two, that is x minus 1, and then the depressed polynomial, which is x squared plus x minus 6. But for this depressed polynomial, it is written as a quadratic. Hence, we need to factorize it. So x squared plus x minus 6 can be rewritten as x squared. Then we have a negative 2x plus 3x minus 6. That is to say, the factor pairs of 6 that we are using to expand is a positive, or let's say a negative 2 times positive 3. You see, if we multiply this, we are going to get what? A negative 6. And if we add it as well, we are going to get the b here, which is what? 1. You see? So let's do our factorization now. For these two, what do they have in common? We have an x, then into bracket, our x minus 2. And the same applies here, x minus 2. With its coefficient of what? A positive 3. So with that, we have our x minus 2 and then the x plus 3. So we come down here and say, therefore, our p of x, which we originally wrote here as this factor times the depressed polynomial, is going to be x minus 1. Then times, we are no more going to write the depressed polynomial in this state, but rather, we are going to rewrite it as what we have here, which is an x minus 2 and then x plus 3. This then becomes the factorized form of our polynomial p of x. Very simple, isn't it? So we conclude by saying, therefore, our p of x is what? X minus 1, x plus 3, and then x minus 2. Very simple. With this second example, I do hope the understanding is building up. For all the two we've done, you realize that the coefficient of our function, that is the leading coefficient, is what? 1. For the first one as well, our leading coefficient was 1. Let's look at what happens if we actually have a leading coefficient, that is any other number other than 1. So for this question number 3, how do we go about it? It says we should fully factorize p of x equals 2x cubed plus 3x squared minus 11x minus 6. And take note, the coefficient of x cubed here is to the power is 2. And our constant term is 6. So how do we go about it? We have our p of x, which is equal to the 2x cubed and then plus a 3x squared minus 11x minus 6. This is what we have. If you want to use the process we have always used, then you can take the negative 6, which is our constant term over here, and then look for its factors. Some of its factors include definitely a plus or minus 1. You have a plus or minus 2. You have a plus or minus 3. And then you have a plus or minus 6 as well. So any of this works. Now there's also a school of thought that is using the rational root test. It says, take this you have here, that is a negative 6, and divide it by the coefficient of our leading, that is the leading coefficient. You see, so we are taking the negative 6 we have here, and then let's divide it by the leading coefficient. That gives us a negative 3. So with this negative 3, we would look for its factors. And it is a plus or minus 1, a plus or minus what? 3. And then we either work with this. You see? So what happens is, if you actually use this particular method, you reduce the number of trials you would definitely have to make. Because if I want to use 6, and then it appears plus or minus 1 is not a factor, and neither is 2 or minus 2, and then it is plus or minus 3, then I would have wasted time doing all these two. You see? But if you're able to reduce it using the rational, that is the constant term divided by the leading coefficient, we just have plus or minus 1 and then plus or minus 3 to test. You see? So let's do our testing. For now, let's maintain this we have here. So testing, let's say testing for x equals 1. So to test for x equals 1, we have p of 1, and substituting we have 2 into bracket 1 cube, then plus 3 into bracket a 1 squared minus 11 into bracket an x, and then minus 6. Simplifying, we have 1 raised to the power 3, that gives us a 1. 1 times 2 gives us a 2. Then we have 3 times 1 gives us a 3. Then, not forgetting our x was 1, so I needed to substitute that here, so times 1. So negative 1 times 11 gives us what? A negative 11. And then we have our minus 6. 2 plus 3 gives us a 5. 5 minus 11 will give us a negative 6. Negative 6 minus 6 will give us a negative 12. This is not a factor. Why? Because the factor or the remainder theorem says the remainder has to be 0 in order for us to consider it as a factor. You see? So since 1 is not a factor, you can test for another number. This time around, let's just go straight and then test for x equals minus 3. So I would say testing for x equals minus 3. So substituting, we say P of minus 3 is going to be 2 into bracket negative 3 cube, then plus 2 into bracket negative 3 all cube, then plus 3 into bracket negative 3 squared, then minus 11 into bracket negative 3, then minus 6. Simplifying, we have 2, then negative 3 cube. That is 3 times 3, 9. 9 times 3 gives us a 27. But then since there is a negative, we have negative 27. Then plus 3 into bracket 9 squared gives us a 9. Then negative 11 minus 3 gives us negative 11 times negative 3 gives us a positive 33. Then minus our 6. Simplifying further, we have 2 times 27. That gives us a 54, a negative 54 because of the negative we have here. Then 3 times 9 gives us a positive 27, then plus 33, then minus 6. Now, if you have to evaluate all of this, that is negative 54 plus 27 plus 33, that will give you a 6. Then minus 6 will give us a 0. So if we tested for x equals negative 3, then it simply implies that x plus 3 is a factor. You remember how I told you we get this? So that is you equating your x minus x equals negative 3, right? Then making x the subject. Give you x plus 3 is equal to 0. So that is what we've done over here, you see. Hence, x plus 3 is a factor. So if you have one of the factors, what are we going to do? We are going to divide our polynomial by what we had as our factor. So the polynomial is what we have over here. So I'm just coming to copy it. And then we come and then do our long division. So we have it this way, and then we start our division. So with this, we say x into 2x cubed, how many times? By now, you should quickly be able to tell. If there's still a problem determining your quotient, you can always check on the playlist where we did the division of polynomials. So we have what? X times a 2x squared. And x times 2x squared gives us a 2x cubed. Then 3 times 2x squared gives us a positive 6x squared. After which we do our subtraction. So 3 minus 6 gives us a negative 3. So we have negative 3x squared. Then we can bring the remaining down as well. So that is to say we have a negative 11x minus 6. As we know, this would be cancelled out because it is just the opposite of itself. We start the whole process again. So x divides a negative 3x squared how many times? A negative 3x. So x times negative 3x gives us a negative 3x squared. Then we have 3 times negative 3x. That gives us a negative 9x. That will be all for now. And then we do our subtraction. So negative 11 minus negative 9. That becomes a negative 11 plus 9, which then gives us a what? A negative 2x. Then we have our minus 6 also coming down. We do our division for the last time. X divides negative 2x how many times? That is a negative 2. So x times negative 2 gives us a negative 2x. Then 3 times negative 6 gives us a negative 3 times negative 2. That is this 3 times the negative 2. We then have a negative 6. So we do our subtraction and you realize that there will be nothing left. Hence, our polynomial p of x can then be rewritten as this factor we have here. That is x plus 3 times the quotient, which is the depressed polynomial. So 2x squared minus 3x minus 2. Now we would have to factorize the depressed polynomial as well. So with a depressed polynomial, we have a 2x squared minus 3x minus 2. If we multiply a by c, we are going to get what? A negative 4. So what are the factor pairs of negative 4? That when we add or subtract, we are going to get a negative 3. That is a negative 4 times 1. That works. Hence, instead of what we have here, we are going to write a 2x squared, then plus x minus 4x minus 2. Factorizing in 2's, we have x out, then into bracket a 2x plus 1. And the same thing here. Then we get our coefficient, which would then be a negative 2. So since these two brackets are the same, we have our 2x plus 1. Then in another bracket, we have x minus 2. This is the factorized form. It then implies that our p of x is written as what? The x plus 3. So x plus 3. Then in the other bracket, our depressed polynomial, which has been factorized into this form. So we have 2x plus 1. Then in another bracket, we have x minus 2. So this becomes the what? The fully factorized form of the polynomial we were given. Now, with this knowledge we have on factorization of polynomials, we can extend it to finding the roots of a cubic equation or solving for a cubic equation. So for all we did, they were expressions. You see, so this time around, let's take an equation and see how we can find the root or how we can solve for the equation. So looking at our fourth example we have here, it says solve by factorization. We have solved the cubic equation x cubed minus 2x squared minus 5x plus 6 is equal to 0. We should solve it completely. This time around, it is equal to 0. So how do we go about it? We know the function is what? X cubed, then minus 2x squared minus a 5x plus 6 is equal to 0. The best thing we can do is to factorize. If you're able to factorize, then you now equate each bracket to 0. So to factorize, let's take the 6. Now for the 6, its set of factors, we have plus or minus 1, we have plus or minus 2, a plus or minus 3, and then a plus or minus 6. And we can test with any of these. It's up to you the number you want to take. But I've always advised that you should start with 1. The 1 and negative 1. You see? So let's test for x equals 1. So x equals 1. Now if x equals 1, then it simply implies we have 1 cubed minus 2 into bracket 1 squared minus 5 into bracket a 1, then plus the 6. This gives us a 1 minus 2 minus 5 plus 6. 1 minus 2 gives us a negative 1. Negative 1 minus 5 gives us a negative 6. Negative 6 plus 6 then gives us what? A 0. So it simply implies that if x equals 1, then x minus 1 is a factor. You see? So if x minus 1 is a factor, then we can start our long division with this first factor we have so that we get the remaining factors and then we can solve for the cubic equation. Hence, we do our long division. So we have x cubed minus 2x squared minus 5x. And as you can see, all these are already in descending powers of x. So there's nothing to be cautious about. X divides x cubed, x squared. Then x squared times x, we have our x cubed. Then negative 1 times x gives us a negative x squared. If you have to subtract, what do we have? Negative 2x squared minus negative x squared. That gives us a negative 2 plus 1, which becomes a negative x squared. So you have negative x squared minus 5x, then plus 6. As usual, this cancels out. Then we start the whole process again. So negative x squared divided by x, that gives us a negative x. So x times x gives us what? That is x times negative x gives us a negative x squared. Then negative 1 times negative x, we have a positive x. Then we subtract once again. So we have negative 5x minus positive x. That gives us a negative 6x. So you have our negative 6x plus 6. That is bringing this down here. Then we go over our division again. You know, the criteria to stop the division is when the degree of this is greater than the degree of what we have here. In this case, it is not. It is actually equal. So we can still proceed with our division. Hence, x divides negative 6x, negative 6. Then have x times negative 6 giving us a negative 6x. Then negative 1 times negative 6 gives us a positive 6. If you have to subtract, you get nothing in return. Hence, it implies that our cubic equation, that is x cubed minus 2x squared minus 5x plus 6, can be rewritten as our divisor, which is x minus 1, then times the depressed polynomial, which is x squared minus x minus 6, which in this case is our quotient. Since this is a quadratic function, then we would have to factorize it as well. So the factor pairs of negative 6, which when added will get a negative 1, is definitely the negative 3 and 2. So we have x squared plus 2x minus 3x minus 6. Factorizing this, we have our x plus 2. And then for this side, we have our negative 3 also with an x plus 2, which then gives us an x plus 2 and then an x minus 3. So it simply means that this whole thing we have right here is going to be changed and then be written as, instead of the x squared minus x minus 6, we are going to rewrite it as into bracket x plus 2 and then x minus 3. Now we have done just the first part of the question. We have factorized it, but then we're asked to solve. You see, so since we want to solve, we said x cubed minus 2x squared minus 5x plus 6 is equal to 0. Hence, this whole bracket we have here also has to be equated to 0. So that instead of this whole thing, we can't just equate each time to 0. We'll be rewriting it as x minus 1, then x plus 2, and then x minus 3 is equal to 0. So with that, you take your brackets one after the other. You see, so we start by saying it implies that x minus 1 is equal to 0. And if x minus 1 is equal to 0, making x the subject, our x is equal to 1. Then we come to the second bracket. X plus 2 is equal to 0. If x plus 2 is equal to 0, making x the subject, then our x is equal to negative 2. Then for the last one, x minus 3 is equal to 0. So if x minus 3 is equal to 0, then x is equal to a 3. So we can conclude by saying Therefore, x is equal to 1, -2, or a 3. As simple as that. There are so many questions that can be asked on factorization of polynomials, as you have seen. But we'll end this lesson here so that we can proceed with another lesson on this course. As usual, I'll leave you with some exercises so you try on your own just to test your understanding. So here are 5 questions you can try on your own. You pause and then complete just to master what we have done. If there's any issue of concern, you can always let me know at the comment section. When I'm notified, I'll address that for you. Let's have beyond numbers or learn maths the easy way. If this is your first time on this channel and so do wish, you can choose to subscribe. That anytime I release a video, you'll be notified to come and then learn with us as well. See you in our next lesson. Stay blessed and bye for now.